Hi everyone. I have a few examples over here which this function or the function here involve the exponential function and polynomial. So if there's a function consists of a polynomial and exponential, and if the operation between them is a multiply, then we have to apply the product rule. If let's say we have a function which is in quotient form, then we have to use the quotient rule. Let's see the first example. dy dx. I'm going to find this. Define the x as my u and the ex squared as my v. Then write down your u as your x, get your u prime. Because I plan to use the product rule, I need the u prime. U prime equals to 1 and the v equals to e power of x squared. So the v prime, the formula to differentiate e f x is f prime x, e f x, meaning that we need to differentiate the x squared, we get 2x. And then copy itself back, you get the ex squared. So this is your v prime. Then now I'm going to apply this product rule. I got my u v prime, v u prime, and just substitute your u and v prime. You get the 2x squared e power of x squared, because as multiplied by this, you get 2x squared e power of x squared, plus v u prime. V is your e power of x squared. U prime is 1. Look at these two terms, both containing the e x squared. So I'll factor out the e power of x squared. First term, you have your 2x squared. Second term, when you take out this, factor out the e x squared, you just left on 1. This is your answer for the question A. And the next example, I have a square root of x e power of negative x. Again, I will let this become this u, and the other this become the v. Okay, then later on we'll apply the product rule. So if a u as a x power of 1 over 2, because the square root of x is a power of 1 over 2, then u prime, you differentiate the u prime, you get a 1 over 2 x power of negative 1 over 2. Differentiate it, you get this 1 over 2 square root of x. Then your v, if your v is a e power of negative x, then the v prime will be negative e negative x, meaning that differentiate the power, you get negative 1, and then copy itself back, you get e power of negative x. Then you can rearrange it to get this. Okay, this is your v prime. Then you can proceed to your dy dx. Dy dx is again, this is a multiply, so we're going to apply the product rule. We get a u v prime plus a v u prime. The u v prime, u multiplied by v prime, you will have a square root of x, multiplied by a negative 1 over ex, plus v u prime. V is your e power of negative x, which is I said that 1 over ex, multiplied by a u prime, that will be a 1 over 2 square root of x. Then now we just simplify it. Simplify, we just take out this 1 over ex, and inside the bracket we have a negative x, square root of x plus 1 over 2 square root of x. What can we do now is you can see that inside the bracket, we can actually equate in denominator. Equate the denominator, meaning that this originally this is over 1. So now I want to make the denominator to be 2 square root of x. So this is need to multiply by 2 square root of x over 2 square root of x. Finally, I will get a negative square root of x multiplied by 2 square root of x, you get negative 2x. And this one you got 1. Okay. So then we'll check, is there any space to simplify? If I think this is the final answer. Alright, you can leave this as your answer. Then now we move to the next example. Again, I have this polynomial 3x power of 4 multiplied by e power of negative x squared. I will take this as a u and this as my v. So if your u equals to 3x power of 4, u prime will be 12x power of 3. If your v equals to e power of negative x squared, then your v prime will be negative 2x e power of negative x squared. Alright, negative 2x, okay, correct. Then proceed to the product rule. U v prime plus v u prime. U is your 3x power of 4, and the v prime is a negative 2x e power of negative x squared, plus v u prime. V u prime is e power of negative x squared multiplied by u prime, 12x cubed. Then now we have two terms over here. We have to check, is there any common factor that we can factor out? And see that this is a 3 multiplied by 2, 6. 6 and 12, there is a common factor, that is 6. And x power of 4, here we have an x power of 3, we can take out x power of 3. E power of negative x squared, here also containing e power of negative x squared, we can take out e power of negative x squared. After you take all this out, then you have a negative for the first term, you have negative inside the bracket, and then you have 1x inside. Alright, sorry, you have a 2x inside. Because here you have an x power of 5. Factor out the x power of 3, you got x squared. Alright, and plus. this one, for the second term, you have taken out this e, and then the 12, you take out the 6, you have 2. X cubed take out, then that's it. You have this answer. Alright, 6x cubed, e negative x squared multiplied by negative x squared plus 2. You always can check the answer by just expanding back, see if you get back what you have on here. Alright, then after that we have d. D is in quotient form, which we have a top function and the lower function. The top function is a u. We always define this as u because we know later on we need to apply the quotient rule. So now I define the u as my ex. Get your u prime, you get ex too. Then v equals to x power of 1 over 2. Get your v prime is 1 over 2, x power of negative 1 over 2. Simplify, that will be 1 over 2 square root of x. Then dy dx for the quotient rule, you have a v u prime minus u v prime over v squared. What is your v? V is your square root of x. U prime will be ex, minus u will be the ex, and v prime will be 1 over 2 square root of x over v squared. That will be a square root of x squared, you get x. Then check. Yes, these two terms, we have two terms over here at the numerator. Two terms. Check. The two terms, is there and contain any common factor? Yes, we can take out. Ex, both containing ex. So take out the ex, I have my square root of x minus 1 over 2 square root of x inside the bracket. After that, the bracket over here, I think this can be simplified. You get your ex and then equating denominator, meaning that these are, you need to multiply by 2 square root of x. Down here, multiply by 2 square root of x. Then you have your 2x on top. Alright, 2x on top and minus 1 over 2 square root of x. Then don't forget you have over x. Alright, you have over x. Continue over here. Then you can have your, the 2 square root of x can take out. You have your ex over 2 square root of x multiplied by 2x minus 1. And don't forget this is something over x. And the x can join with here. Can join with this. You get the 2x power of 3 over 2. Because a over b over c, you can write into the form of a over bc. bc meaning that you're taking these 2 square root of x multiplied by x, you get x power of 3 over 2. And in the bracket, you got a 2x minus 1. Alright. Proceed to the example E. The next example, again, I will let this become u, this become the v. And later on, we're going to apply the quotient rule. U equals to e power of 3x, then u prime will be 3e 3x. If your v equals to 1 plus x, then your v prime is 1. So now, formula for the quotient rule, v u prime minus u v prime over v squared. So get your v, okay, v 1 plus x, multiplied by u prime, that will be a 3e 3x, minus u, that will be e power of 3x, multiplied by v prime, that is 1, over v squared, that is 1 plus x squared. After that, I want to take out the common factor. Factor out the common factor, you get the 3e power of 3x. Then first term, you have your 3, 1 plus x minus 1, over 1 plus x squared. Simplify what is inside the bracket. You can simplify. 3, you have a 3 minus 1, that will be 2. Okay, 2 plus 3x. 2 plus 3x over 1 plus x squared. Yes, this is the answer. Alright, final. This is the final example. You have your u and the v. Okay, so u is your ex. U prime will be ex. v, ex plus e power of negative x. So v prime, differentiate the ex, you get your ex. Differentiate e negative x, you get negative e negative x. Alright, then you're going to apply the quotient rule. That is your v u prime minus u v prime over v squared. So v is your ex plus e power of negative x. Multiply by u prime, that will be ex. Minus u is your ex. Multiply by your v prime is your ex minus e power of negative x. Over v squared. Ex plus e power of negative x squared. Then we can factor out the ex. We have, take out the ex, we have ex plus e power of negative x minus e power of x plus e power of negative x. Because this ex, you factor out this ex. Both terms containing the ex, I take out ex, I put it here. Alright, then inside the bracket we have ex plus e negative x will be here. And minus ex plus. Why plus is negative multiplied by negative, you get positive. Okay, this is inside the bracket and over ex plus e power of negative x squared. So now we can see that this one and this term can be cancelled off. And what we left is ex here, and now we have a 2e power of negative x. Okay, we got 2e power of negative x over ex plus e power of negative x squared. And you can see that e power of negative x, what does it mean? This means you can also write this in this form. Down there, you still have the ex plus e negative x squared. You can see that these two actually can be cancelled off. And finally, we only have the answer 2 over ex plus e power of negative x squared. Alright, so there's two more examples. Okay, I will record in the next video, which later on you search for the video for part 2. Thank you. Hi everyone, this is the part 2 of the video for the question 5, question 5, which is differentiating the exponential function. Now for this question, we have a function in the form of a quotient form, which the u, okay, the top function is sex, and I define it as a u, and lower function is x plus ex, and I represent it as a v. Because later on, I'm going to apply the quotient rule, which this is a v square quotient rule. Later on, so the quotient rule needs our u and the v, u prime and the v prime. So to get the u prime, meaning that we are going to differentiate this sex, I'm going to apply the product rule. Let this become the u, this become the v. So formula to get this product rule, we are copy one of the function, copy down one of the function, differentiate the other function, that is a ex. Differentiate ex, you get ex. And then copy down the other function, that is a ex, and differentiate the function that you just copied down just now, that is a differentiate x, you get 1. So you get sex plus ex when you get the u prime. So to get the v prime, this is simple. Differentiate x, you get 1, and differentiate ex, you get ex. Now we can substitute into our quotient rule to get the dy dx. Get your v, because v multiplied by u prime, copy down the v, and then multiply by the u prime, you get the ex plus ex, minus, copy down the u, that is your ex, and multiply by v prime, which is your 1 plus ex. And all this over v squared, divided by v squared, which is your x plus ex squared. And now I'm going to expand this. See, I can simplify. I got my x squared ex. When x multiplied by x I got x squared ex. And x multiplied by ex, I have x. And this one you have x e2x, because ex multiplied by ex, you get ex squared, which is equivalent to e power of 2x. Ex multiplied by ex, which is e power of 2x. Alright, minus, expand the second term, you have the x minus x e2x. Later on, we're going to check the numerator if there is any like term that we can combine or cancel off. Sex and sex we can cancel off, minus positive sex and negative sex. And what else that we can cancel off? This is se2x and this is also se2x, and they are opposite signs, so we can cancel off. And what we left is x squared ex plus e2x. So we can factor out the common factor, which is your ex, e power of x, we can factor out. And when the first term factor out the ex, you have your x squared. Second term, you factor out the ex, you have another ex over x plus ex squared. Alright, so this and this is different, cannot be cancelled off, and this is our final answer. Let's move to the final question, which is y equals to is a polynomial multiplied by exponential function. So for this question, I will apply the product rule, because the polynomial and the exponential function, the operation between them is multiply. So this becomes the u, and the second becomes the v. U equals to x squared plus 2x. To get the u prime, differentiate, you get 2x plus 2. And the v equals to e power of x squared plus 2x. So to get the v prime, you're going to apply the formula, which is differentiate the power, you get 2x plus 2. And this is going to multiply by the function e, which is ex squared plus 2x. Alright, then now we move to the product rule. To get your dy dx, we are going to apply this product rule. u v prime means that we're going to take this x squared plus 2x, multiply by v prime, which is your 2x plus 2, multiplied by e power of x squared plus 2x, this is your v prime, plus, copy down the v, which is your ex squared plus 2x, multiply by u prime, 2x plus 2. And all this divided by v, this is a product rule, so you don't have to divide. Okay, then we simplified it. simplify it, okay, by factor out the e power of x squared plus 2x. Inside the bracket, we have x squared plus 2x multiplied by 2x plus 2, so I can actually expand it first. I got my 2x power of 3 plus 2x squared plus 4x squared plus 4x. This is what I get when I expand this. And plus 2x plus 2. Second term, when you factor out the e, you left 2x plus 2. Then later on, we're going to check the bracket. In the term inside the bracket, is there any like term? You can just combine them. 2x cubed, there's only one term, so this is a 2x cubed. And the x squared term, we have 6x squared and plus 6x plus 2. Again, I see that all these four terms are containing the common factor 2. I can factor out the 2. And what we left is x cubed plus 3x squared plus 3x plus 1. Alright, this is our answer. Thank you for watching.